A very good morning to all of you. In this session, we are discussing about inference in first order logic. In the previous session, we have already seen what is first order logic and we have also discussed some of the examples. And here we will discuss what is inference in first order logic. So it is a process. Inference is a process of deriving new knowledge from what is already known. So we will start from the knowledge base. So knowledge base having facts and rules will be there. That means existing sentences, or we can say that whatever we already knows. So that is available in the knowledge base. So using inference rules, we derive new conclusions. And these conclusions must be logically entailed by the knowledge base. So we can simply say that inference is reasoning logically, it is not guessing. So inference rules are actually a templates of valid reasoning. So they tell us how to move from premises to conclusions. In AI, this inference rules actually help us to help an agent to answer the queries and also to prove the goal and make decisions. We can say that a proof in AI is simply a sequence of inference steps that leads from knowledge facts to the required goal. So, if we have, for example, if we have in the knowledge base, we have some sentences and we can derive new conclusions from these sentences by applying the inference rules. So, we will see different types of inference rules. So we have a set of premises or facts. We can consider it as P1, P2, P3, P, etc. up to Pn. And we have to prove one conclusion Q. So an argument is valid if the premises logically involve the conclusion. So all the inference rules take us from the premises to the conclusion. So if premises are true, then the conclusion must be true. So we will see these are the types of inference rules: modus ponens, modus tollens, hypothetical syllogism, destructive syllogism, constructive dilemma, destructive dilemma, addition, simplification, conjunction, and resolution. So we will see one by one. The first one is modus ponens. So it states that if P and P implies Q are true. So here this is the representation of inference rules. Here we are drawing a line. Above line what are required, that is actually the premises. Here you can see that here P implies Q and P are true. So P implies Q and P are true. Then we can infer that whatever will be our inference that we are writing down at this line. You can see here, therefore Q. So Q will be true. So according to the modus ponens, it is telling that if P implies Q and P are true, then Q will be true. So with example we will discuss. If we are considering if I am sleepy, then I go to bed. So I am considering it as I am sleepy as P and I go to bed as Q. So if I am sleepy, then I go to bed. We can represent it using implies. So if P is true, then Q will be true. That I am writing it as using implies. Then I am sleepy, I am taking it as P. Then I can simply say that from these two sentences, I can conclude that if P is true and then P implies Q, then I can say that Q is also true. So my conclusion is I go to bed. Then go to the next one. So next is actually modus tollens. So modus tollens where it states that if P implies Q is true and not Q is true, then not P will be true. So we can see the notation. Our initial condition is P implies Q is true and not Q is true. Then our conclusion, we are writing down this line, that is not P. So we will explain with an example. So if I am sleepy and I go to bed, that is P implies Q. So P is I am sleepy and go to bed is Q. So if I am sleepy, then I go to bed, I can represent it as P implies Q. So that means if P happens, then Q will happen. Then here, according to the modus tollens, not Q is true. So that I am writing Q is I go to bed. So I do not go to bed is true. That is not of Q. So that means I do not go to bed means that means I am not sleepy, right? So the conclusion which infer that I am not sleepy, that is not P is true. Then next is hypothetical uh, syllogism. So according to this, here you can see that P implies R is true and P implies Q is true. Then um, and Q implies R is true. So this we can represent it as it's given that P implies Q and Q implies R, and our conclusion will be P implies R. So we will see with an example. If I have my home key, then I can unlock my home. So here I have my home key is P. Then I can unlock my home is Q. So that, according to this sentence, we can write if I have my home key, that is if P is true, then you can unlock my home. So that is Q is true. So I can write P implies Q. Then next sentence. If you can unlock my home, you can take my money. Unlock my home, we already take it as Q. So Q implies you can take my money. So I can write another one, that is take my money is I can let it as R. So it will be Q implies R. So by conclusion, I can say that if I have my home key, then I can take the money, right? So I can simply write P implies R. Next is destructive syllogism. So in the case of destructive syllogism, it is telling that if P or Q is true, P or Q is true and not P is true, then Q will be true. So P or Q is true, that means either P or Q is true, and it is given that not P is true. Not P is true means P is not true, right? Then Q should be true. So we will explain with an example. My statement is today is Sunday or Monday. So today is Sunday is P. Today is Monday is Q. So P or Q, I can P or Q. That means today is Monday or Sunday. So I can represent it as P or Q. Then another statement is today is not Sunday. So it is given that it is not Sunday, right? So first sentence is true. It is given that first sentence is true. That is P or Q. So today is Monday or Sunday. And second sentence it is given that it is not Sunday. And we can conclude that it is Monday. So today is Monday. That is Q is true. Here also you can represent, you can see that whatever in the knowledge base, it is given above this line and below the line. Uh, that is our conclusion or inference. Next is addition. Addition rule is one of the common inference rule. It states that if P is true, then P or Q will be true. So P true means we can add another one. We can say that P or Q. So that means whatever it is doesn't matter. P or Q means either P or Q will be true. So we have already given that P is true. So we are not bothered about whether Q is true or not. So here you can see I am taking, I have a vanilla ice cream is P and I have a chocolate ice cream that is Q. Then I can write P or Q. So that means I already knows that I have a vanilla ice cream. Then it doesn't matter that I have a chocolate ice cream or I have or have not. It doesn't matter there. So I can simply say that P or Q. So P or Q means either P or Q will be true. So it's already given that P is true. So I'm not bothered about Q. So I can simply write P or Q without knowing Q is true or false. Then simplification. So simplification rule states that if P and Q is true, then Q or P will also be true. It can be represented like this. That means here I can write P and Q means Q is true. I can say that Q is true. And P and Q also I can say that P is true. So I can just simplify it as a two sentences actually. That means here you can see that Vipin plays football is P. Nicola plays tennis is Q. So here it is given that Vivin plays football and Nicola plays tennis. That is P and Q. So I can say that Vivin plays football. That is my conclusion is P. And I can also tell that Nicola plays tennis. So that is my another conclusion. That is Q. So here I can come P or Q. I can simplify it as Q or P and Q. I can simplify it as P. Here you can see that next one is constructed dilemma. It is given P implies Q and R implies R, and also the third one P or R. Then our conclusion will be Q or S. So we will discuss with an example. If it rains, I will take a leave. So P means it rains. Q means I will take leave. So I can conclude that if it rains, not conclusion. If it rains, I will take a leave. So that is one fact. That is P implies Q. Then, if it is hot outside, I will go for shower. So it is hot outside is R, and I will go for shower is S. And it is given that it is either rains or hot outside. It is given that P or R. So either P is happening or R is happening. Then I can say that if P is happening means Q is happening. If R is happening means S is happening. So I can say that either Q or S is true. So it is given that P implies Q and R implies S, and also it is given that either P or R is true. Then I can conclude that either Q or S is true, because if P is true, then Q is true. If R is true, then S is true. So it is given that either P or R is true. That means it is if it is rains or it is hot outside. Then I can conclude that I will take leave or I will go for shower. Next is destructive dilemma. Here it is given P implies Q and R implies R, and not Q or not S is true. So that means if it rains, I will take leave. If it is hot outside, I will not go for shower. And it is given that I will not take leave or I will not go for shower. So I can say that I will not take his leave is true, then that means that it is not raining. I will not go for shower is true means it means that it is not hot outside. So I can say that either of not P or not R is true. That means therefore it is does not rain or it is not hot outside. Next rule is conjunction. So this rule states that if P and Q are simultaneously true, then the formula will be P and Q. So we already know this. Here you can see the example. Nivin plays football, that is P. Vivin plays cricket, that is Q. Then we can conclude that Vivin plays football and cricket. So here you can see P is true, Q is true. Then we can conclude that P and Q is correct. Then resolution. Resolution states that P or Q or not P or R is true. Then we can conclude that Q or R will be true. So here the notation will be like this: P or Q and not P or R is true. That means our conclusion will be Q or R is true. We will explain with an example. Here we are taking P is it is raining, Q is ground is wet, and R is sprinkler is on. And it is given that P or Q is true. So that means either it is raining or ground is wet. Then not P or R is true. So that means either it is not raining or sprinkler is on. So that means here when we are comparing these two sentences, it is given that in the first sentence it is given that it is raining, and second it is given that it is not raining. So that means apply resolution and these two will cancel each other. They are contradictory, so P and not P will cancel. So we can say that either Q is true or R is true. That means ground is wet or sprinkler is on. So our conclusion will be Q or R is true. So that means either the ground is wet or the sprinkler is on. We can say using inference rules how we will find the conclusions. So here we can see that we have a set of sentences. First one is if you smoke or drink too much, then you will not sleep well. If you do not sleep well, you do not eat well, then you feel rotten. If you feel rotten, you do not exercise well and do not study enough. You do smoke too much, therefore you do not study. So we have to prove you do not study. So for that, first we can represent each with a corresponding values. Here you can see I can represent each sentence. Here we can see that in the arguments we are converting each into a symbol form. You can see here first sentence if you smoke or drink too much. So that means if you smoke too much, I can represent it as drink too much. D. Then sleep, not sleep well. So sleep well, I am putting it as W. And then eat well, E. And then feel rotten, R. And then you can see exercise well, X. And study enough, that is T. So we will see how we can convert this facts into simple form. So first one, if you smoke or drink, so I can write S or D. Much, then you do not sleep well. So that implies that not sleep well. So not of W. Then you can see sleep well, and I am putting it as a symbol. Then if you do not sleep well, so not of W, or do not eat well, so not of E. Then means implies you feel rotten, so implies R. So it is written S or R. Smoke too much and drink too much, or drink too much. Then using, we will represent it using implies not sleep well. Then there is an and. So and we will represent with the and operator. Then you can see here it is given that not sleep well. So not W, not eat well, not eat well. So not of E. That then means implies you feel rotten. That is R. Then second sentence, if you feel rotten, so I am putting R implies do not exercise. So not of X, and there is an and operator. So and not of T. Then you do smoke too much. So only S. Then you do not study well. That is not T. So we have to prove that you do not study well. So study enough. So from the first sentence itself, we will start and we will apply the inference rules and we will find the conclusion. So we will start with the first one. S or D implies W, and not of W, not of E implies R. So from this sentence, we can see how we can write it. So we are starting from the first one. It is given that first one, S or D implies not W, and not W or not D implies R. So we know that according to the simplification rule, this we can consider it as P. That is S or D implies W. And the remaining portion we can represent it as Q. So not W or not E implies R. So according to the simplification, P and Q is true. That means P is true. Or you can write it as Q is true. So here I am writing, I am doing the same thing. By applying simplification, I am getting the fifth point, that is P. That is S or D implies not W. Then I can write Q is true. So it will be not W or not E implies R. Then according to our given facts in the knowledge base, there is a third one, that is S. So we can do the addition. So addition I am writing S or D. So I can write any symbol because here I am not bothered about D is true or false. Anyway, S is true. So that means S or D is also true. Then we can apply modus ponens. So according to the modus ponens, um, P implies Q is correct and P is correct means Q is correct. So this is P implies Q. And according to the seventh fact, we know that S or V is true. So S or V is true means that is not W is true. So I can write it as the eighth fact, that is not W. Then we can write the addition property. We can write it with the not W or not E. Now it is similar to the sixth point. We can see that not W or not E implies R. And we know that not W or not is true. So that means R is true. That is P implies Q is true and P is true means R is true. So I got R is true as the 10th point. Then according to the initial facts, we have second one is R implies not X and not P, and we know that R is true. So that this is also similar to P implies Q. So we can say that not X or not W is true. So we got 11th factor, not X or not T is true. So this is similar to P and Q. So here we can conclude that not 3 is true. So that is in the case of P and Q, P is true, or P and Q is true means Q is true. So here I am putting not T is true. So our final conclusion, therefore you do not study. Another example you can see. If the Bible is literally true, then the earth was created in 6 days. If the earth was created in 6 days, then carbon dating techniques are useless, and scientifics are frauds. So the scientists are not frauds. The Bible is literally true. Therefore, God does not exist. So we have to prove the last one, that is, God does not exist. So here we will see. We will put, first we let us symbolize as follows. We are taking Bible is literally true is we are taking it as E. Earth was created in 6 days. We are putting it as E. Carbon dating techniques are useless, so it is C. And scientists are frauds, yes. And God exists is G. That we have to prove it. So the first sentence, from the first sentence I can write, if Bible is literally true, that means the earth was created in 6 days. So I can write B implies E. So if B is true, then E is true. Then according to the next sentence, earth was created in 6 days, then carbon dating techniques are useless and scientists are false. So I can write when E is true, then C and S is true. So E implies C and S. Next, scientists are not frauds. That is the third sentence. So we are putting not of S. Then the Bible is literally true. So B is true. Then last one, God doesn't exist. So not G. That we have to prove it. Here we will see how we can solve it. So we are considering the first one. B implies E. That is P implies Q. And we know that fourth one, that is B is true. So P implies Q is true and P is true means E is true. So we can write it according to the monosponence, E is true. Then E is true and then E implies C and S is true. So that means C and S will be true. Similar to the first one. P implies Q and P is true means Q is also true. Then after getting C and S, I can write C and S using simplification. I can simplify it as S is correct. So that means P and Q is correct means Q is correct. Similar to that, I can write S is true. So here S is true. By using addition, I can add S or not G is true. So if I can add anything, it doesn't matter because S or D means either S or that not G is true. So S is already true. It is given. So I can say that not G is true or false, whatever it is, doesn't matter. That is addition. S or not G is true. Then we can apply here S or not G. Then we can apply destructive syllogism. According to the destructive syllogism, P or Q, here we can write P or Q is true, then and not P is true, and not P is true, then I can say that Q is true, then Q is true. So here according to this destructive syllogism, S or not G is true, and it is given that not S is true, not S is true. So not S is true and S or not G is true. That means Q is true. So Q is true means not G is true. So we proved that uh, God doesn't exist. Next example, it is given matter always existed. If there is God, then God created the universe. If God created the universe, then matter did not always exist. Then we have to show that there is no God. So here, let us symbolize as follows. Matter always existed. I am taking it as M. There is God. I am taking it as G. And God created the universe. I am taking it as U. So all this already we have assigned. So we will see how we can write into a symbolic form. You can see first one, matter always existed. So I am putting M is true. Then if there is God, then God created the universe. That is G implies U. If God created the universe, God created, that means U. Then matter did not always existed. So that is U implies not M. Then we have to prove that not G. That is there is no God. So we will see how we can solve it. So we will see how we can solve it. Here you can see that first we can apply hypothetical syllogism in 2 and 3. So here you can see G implies U. I can take it as P implies Q and U implies M, not M means I can take Q implies R. So we have already discussed this. If I have a honky, then I can unlock the room. If I unlock my room, I can take money. So I can simply say that if I have the home key, then I can take the money. So that means P implies R. Similar to this, I can write G implies not M. So G implies not M. So this is the next fact. Then if I am considering this and M is true. So M is true means according to the modus clemens, P implies Q is correct, Q implies Q is true, and not Q is true. That means not P is true. So here not Q is true. That means M is true means not of Q is true, right? So I can say that not G is true. So there is no proof, which is true here. Thank you.